This conference will now be recorded.
Okay, guys, good morning, good evening, and good afternoon. So welcome to today's session. At the beginning, Xin will share some house cleaning information. Then we will go into the HLD review for two features contributed by the Broadcom. One is the CMIS diagnostic. The other one is the system ready enhancement. So Xin, you can go ahead.
Thanks, Yan Zhao. Good morning, everyone. That, as you know, OCP Summit is coming. That is in the beginning of November. That at this stage, the presentation for OCP Summit has been selected, and the schedule has been published on OCP web. That the OCP staff and the presentation owners are going through processes to create the draft deck and iterate on that. What I'm going to chat about here is about OCP, is about the SONiC workshop. That we have many submissions of the OCP summit that could not make to the main conference due to limited space, and that would like to ask for feedback about the SONiC workshop. What is a good time? The purpose of SONiC workshop, SONiC Science workshop is like around 1 day of SONiC and Science focused technical talk that talk about either the latest status, contribution proposals, and innovations for each company. We also used to have that very close or near the OCP, associated with OCP Summit. My question to everyone is that what is a good timing to have OCP SONiC Science workshop? Is that right after OCP summit in the beginning of November, or we could do it a little bit later, like at the beginning of December, etc. The thought there is we have OCP summit on November 9th to 10th. That is a Tuesday and Wednesday. If we right after that we host OCP workshop, which is a virtual one, that does people need to travel like physically attend LCP in San Jose? Does people need to travel back to their hometown, to their countries? So we'd like to get some feedback with the community. What do you prefer, right after the OCP summit, or we could choose a different time, mid of November or beginning of December for a full day of SONiC Sci workshop? Anyone has any opinions or preference? Yeah. This is a community that, yeah, we are keen to hear back from you.
So this is Zhenghui from Juniper. In my personal preference, I would prefer a virtual workshop.
Yeah, it is virtual, but how about timing? Yeah, like November associated, like right after the OCP summit, or mid of November, or the beginning of December?
The
Yeah,
problem
I don't
with the
have.
middle of November is that it lands right on top of SC21 if you're not careful. That's for the 14th through the 19th.
Good point. Very good point. Yeah, we should avoid that. Yeah. How about beginning of December? Or we can do right after the OCP. OCP is Tuesday and Wednesday. We can do it on Friday, giving a day for people to travel back home.
Well, my personal feedback is that to have it just after the OCP, because starting December, it might be that people will be tight with schedule before holidays, vacation. That's my 2 cents.
Sure. Thanks, Iniad. Yeah. Okay. Before that, I hope to like this is a virtual that I know some people will go physically to attend OCP summit in person. At this moment, there is a lot of uncertainty, so that to avoid any churns and to make it convenient for people to plan, that we would like to just make it purely virtual, so people can join online, also make interactive conversations, leave time for questions. Yeah, we had last time we had virtual workshop, and it went well.
Is there an agenda or for this? I think it's a SONiC Sci workshop, right?
Yes, you're right.
Yeah. So is there an agenda or topics that is it posted somewhere?
Yeah, not yet, but we
Okay.
do have a lot of papers submitted to OCP, but they didn't make it to the main conference. That is very limited space. This
Right.
time we have, yeah. So, yeah, we will select from there.
Gotcha.
Yeah. Okay. Seems like there is no very strong opinion, but there is slightly favor to the to close to OCP, so that we can avoid like December, like a holiday time. Yeah. So let's plan. Yeah, let's plan for that. Yeah.
Okay, thank you, Xin.
Yeah. Thanks, everyone.
Okay, so the first session, I mean the HLD will come from Dent. So Dent, I think I make you the present.
Yeah.
That's good. Okay.
Hi, this is Dante from the Broadcom. And could everyone see my screen?
Yes. Okay.
Yes.
Okay, thank you. Great. Yeah, right now we create a feature request for the CMIS support. And please notice the main purpose is to upstream whatever we have in the Broadcom SONiC. So that means it's not using the SONiC transceiver from the SFP refactoring. It's still the existing platform APIs. So yeah, just a note. And here's the requirement overview. That the CMIS 4 was finalized in May of 2019. That's 2 years ago, and now it's CMIS 5. But yeah, it doesn't matter because right now what we are going to deliver is compliant with CMIS 4 and CMIS 5. And it provides a variety of features and transceivers and form factors. And from a software perspective, a CMIS application initialization sequence is now mandatory, which means that if we are having the port breakout, and then the initial sequence will also be necessary for the CMIS modules to activate the desirable applications. Without that, the link will not come up. And the current SONiC platform API models is that all the SONiC platform common will provide a common platform-independent interface that would be SOP-based. The abstract class, the SOP-based, is defined in the SOP underline base.py. And other platforms are supposed to inherit this base class, and the base class will be, in terms, invoked by the transceiver D. And the point is that while we have a base class defined in the SONiC, it's just a symptom, skeletons for the APIs. The platform implementations may reuse the legacy SLP libraries. Oh, they could also create their own. So that causes problems because all the vendors will have to fill in all the implementation gaps by themselves. So it causes troubles to maintenance and also, yeah, the duplicate works. So the goal of the CMIS right here is also to provide a unified common SLP parser, the common SLP library for the CMIS, the KLCP-DD transceivers. And it will also enhance the transceiver D for the CMIS KLCP-DD application initialization sequence. And also, it also provides a basic support for the transceiver physical layer loopbacks. That would be the CMIS diagnostic loopbacks defined in the CMIS 4 spec. So any questions so far?
So one initial comment is that, and this is a bit of a nit, all the references to QSFP-DD actually could be QSFP-DD or OSFP, right?
Yeah, that's right.
And I think I see why you're doing this, right? I think I agree with, trying to do a common implementation for this. This makes a lot of sense.
Okay, thank you.
How is this work related to the SAP refactoring work that is going on?
Just like I said, it's not, but in the future, we'll revisit again to write the interpretation that we're going to discuss in this session. Right now, it's not using the new class defined in the SAP refactory, but it will be revisited later once the SAP refactoring is finalized. I mean, the finalized, I mean, it's for the upstream to the repository. Yeah, I know a couple of days ago it's merged, but yeah, we'll and right now this one is not based on the SAP refactory.
But are we creating a two parallel framework that supports the SAP?
Yeah, right now that's that's right. Right now we we're going to have two different implementation in parallel if this is merged, but it will later be revisited and do best to the SAP refactoring. So for now, it's temporary.
I mean, why? I mean, if the approach you are agree is to the long term is to use the design that we have presented in the community. So why do we need to spend time to on this temporary work solution?
Yeah, Babu, are you there?
Guhan, yeah, my understanding is not many platforms have already migrated to the new refactoring SAP implementation, right? So we still have a lot of them relying on this old implementation. So we still need to continue to support it for some time, right, until they all migrate to the new ones. So from that perspective, I think the solution also will coexist for some time. While that comes in, we will also revisit migrating the solution over to the new refactored SAP classes. So for some time at least, we need to have both in place until all the platforms migrate to the new ones.
But this one also, I think you also change the transfer receiver D, right? So you not only change the platform common, also there are some changes in the X receiver D to use the new logic, right? So, but when we change to the new refactor, the SAP classes, then we'll have to change the transfer receiver D logic again.
I'm not sure I understand how it can work with the existing one if there is a common code, because shouldn't we have like the platform API and whoever wants to use the old or the new one will be able to load it like on the platform, because we cannot reduce let's say functionality just because moving to a new one.
Yeah, that's correct. But so in our current design, we only define a new function skeleton in the SAP space class, and that would be the CMIS application in it, set CMIS application, and also the loopback, and that's all. So, and in this SAP refactoring, we still reuse the base class, the skeletons. So as long as the SAP refactoring classes is still based on the SAP base class, and then from transceivability perspective, they are the same thing. The only difference is how we instantiate all this class. So the changes we made right now could be reused when we all migrate to the SOP refactoring classes. It's not a conflict. It's about what we want and how we want to moving forward on the SAP unified implementations. Does it answer your questions?
Not necessarily if you are changing also common daemons or common code, like not the class. If you are changing some logic in the XLVD, or you are changing some logic in the way that we are getting that information, then I'm not sure how it will work together. This is what I'm not sure about it.
Oh, in that case, we only did extra works, so it will not change any existing logic. It just create an additional CMIS manager, a sub-process.
Which can be somehow not, if there is no SFP-based APIs implemented, then it is like doing nothing?
Yeah, it doing nothing. Because before we initiate this process, it would check for the SIP implementation, which means that the classes must be instantiated from the SIP base class. And also, we are expecting the port type, the catch type, to be SIP QSP DD. And only both of them was applicable, and then we'll initiate this process.
But there is already a support. But there is already a support of QSFP-DD in the SFP, in the monitoring, in the PMON and the XLVD. So what you're saying is what we have today is not enough, or you're trying to provide a different way of implementation?
It's not enough because in the CMIS 4 modules, yeah, just like I said, in the CMIS 4 modules, when the transceiver was updated to using the CMIS 4 firmware, or maybe CMIS 5, and then all the port modes was defined as an CMIS applications. So for example, if we have a CMIS 4 modules and we have the port break out to 4x100, and then the link will be done if that's the CMIS 4 modules. And yes, it will be working if we are using CMIS 3 and it's not causing any issues. But in CMIS 4, the link will be done unless we perform the application initialization sequence to activate the application mode to 4x100. So that's the main purpose that we initiate the CMIS manager. It's the main purpose to, to do the initialization sequence. That's the main purpose. And also because the initialization sequence is actually, trigger it communicate with the CMIS firmware. So it takes a long time. Yeah, in the code review, I remember that it takes only 4 seconds in the Avogadro transceivers, but it could take 15 seconds. Yes, 15 seconds for the Dell optics. So it's really taking a long time for the application initialization. So we cannot do it in one thread. We cannot do it in everything in the serialized. So we have to create it, the multiple process to get everything, to do the application initialization sequence in parallel. So that's the main purpose right here. So that means that what we've done to the transceiver D is only for the application sequence, in application initialization sequence for the CMIS, and that's all. So any questions?
I think it's still the same concern. I think, if we later, go to the SAP refactor work, then we have to change all this CMIS manager logic to adapt to that framework's API, right? So, because I think this is causing the churns in the transceiver decode.
How about this? I mean, earlier when we had 1.0 APIs and then we had 2.0 APIs, we still supported both, right? So I think we still need to do something like that for some time. So we can look into the, supporting the new refactored SFP classes. But somebody has to provide that implementation. But if that is not there, we can fall back to the legacy SFP standard implementations, right? So that way we ensure some compatibility for some time until every platform migrates to the new refactored classes.
I'm not sure I understand. I think the
what I meant was the CMIS manager task today it's relying on the SFP standard, right? But we also have the refactored SFP classes. So what I'm saying is we will support both. If the new implementation is not available, we fall back to SFP standard until all the platforms migrate to the new classes, the refactored ones. Just like how we had 2.0 and 1.0 coexist in all our daemons for a long time.
Maybe you should look into the details, how this manager task can support both.
Yeah, that could be discussed. Yeah.
Okay, I think we should continue. So we get the feedback. Please consider those feedbacks when we review or merge this PR. So let's continue.
Okay, so just like I said, the main purpose is to to make the application initialization sequence to be processed in parallel, because it takes a long time, maybe 15 seconds, like I said. Yeah. So from this figure, you can see that we have multiple CMIS manager tasks, and all the tasks would be extension from the platform-based classes that would be the get chassis. And also using the get SLP to get the SLP objects, and they are all inherited the SLP based class. And right here, we only provide a common class that would be SLP standard, and it provides the common parser and common applications, whatever all the common routines. So now the platform drivers, the platform BSPs, they could just reuse this class if they don't want to do any customization. And in the meantime, they could also inherit this class and then override the functions if they want to have something that's customization in their platforms. It's all possible, yeah. And then in the common SIP standards, we will reuse all the legacy SIP libraries that the KSIP DD, .py, and also the INF A6 to 8. Yeah. So we will reuse everything that we have since 1.0. And so right here, if we take more details that in the transceiver D, it will be modified to post the causability information to StatDB. Yeah, that would be for the application advertisements. And also you will add the CMIS task to handle the multiple CMIS initialization. Yeah, just like I discussed earlier. And in the platform comments, we will update the INF A628.py. That means we will add the support to decode the application advertisement. And also we will add the support to decode the DOM information because it's also missing. And also that it will also do the initialization sequence, but yes, it will be implemented in the SLP standard.py, and that's a new class. Yeah. And this class right now is just using the the platform 2.0. That will be the platform-based API, and it will later be revisited to using the SLP refactoring cases. And in the case of SONiC utilities, the SLP util will also be modified. That means it will be modified to support display the current application mode of the CMIS modules, and also display the current configuration errors when we do the application initialization sequence. Yeah, that's possible. And it will also.
How would the show command will look like? Because it's already full with information. So if you are now adding more to the show command itself, is it going to be how to review the output?
Yeah, it's update the output. We will enhance the output to have the application advertisement.
Yeah, I understand that. I'm asking how it will affect the current way of look, because already we have a lot of information. And if you are adding more information to the existing one, I'm not sure that it goes into one screen, or it is should be kind of divided to a new like parameters for the CMIS. So maybe I think that what you should do is that you should provide a guideline of how the CLI should look like, and then we can provide feedback.
Yeah, sure. Let me share my screen. Okay, the first screen. Yeah, we have a UT in the pull request, the unit test result. So could you see my screen?
Yes.
Great. Okay, so the SRP util will be updated like this. So this one, right now the highlighted sections will be the modified information. So right here for the CMIS modules, we will display the application advertisement for this module. And this one is AlphaGo optics. It supports both 400 gig and also the 4x100. And that will be the application 2. Yeah. So that means when we enable the 4x100, we should also activate the application 2. Otherwise, the link will be down. And also, we will also provide the DOM information, but it's similar to the KSLP 28, but we have more lanes. And in this case, in this showcase, it's a DR4 module, so we only have 4 lanes at line side. So it looks like the KSLP 28, but no, it's actually the CMIS. So what we did modify the SLP util, but the display, the change to the display is
So it changes only
minimal.
it changes only per interface. It's not like, and for that interface you give an extra information, but it's not affecting the commands which are tables, right?
Yeah, that's right.
What you're saying. Okay, understood.
Okay, let me go back to the HLD.
And for still the use of PDD, which exists now and does not support the this version of CMIS, then the same way of how it works right now, there should continue to work. Correct?
Yeah, that's right. Yeah, that's right. Yeah, because the information, if we are using the, if the information is missing in the dictionary, the Python dictionary, and then it will not display. So yeah, it would be compatible. And also, let me check if we have the example for the error descriptions. You know, in the SRP-based case, we have a function that calls the error description. And SRP util will also, yeah, right here. Sorry, it's not captured in this unit, in this UT results. Yeah, maybe I'll update it later. So in the case of configuration errors, in the SRP util, we have the error description. So it will also be integrated into the error description. So it would let user know if the CMIS module application sequence is succeed or fail due to the back application mode or due to the errors in the host site. So whatever, it's something like that. So yeah, it's fully compatible with whatever we have. It's just an enhancement. And as to the loopback, yeah, it's also an enhancement to the existing SRP util, and that would be the loopback. Yeah, for now it's just right. Actually, this one is a debugging tool. So people, they want to enable the loopback and to isolate the issues and quickly do the root cause analyze. So the command would be very simple, and that just for debugging. So anyway, it will be landing in the SRP util, and so. And yeah, that will be the changes to the components. And the changes to the database, that would be minimal because it will only have this one for the application advertisement. Sorry. Go back. Okay, yeah, right here. This one is for the application advertisement, and then the others will only be yeah, that's all. That's the only new thing. Oh, we also have this one, but it's not displayed. So yeah, maybe we could update the SRP util to also support this one in the console, in the output. Yeah, and all the others was about the show comments that we just show you in the UT result. Yeah, I could check it out if you have any concerns. And yeah, also the DOM information. Yeah, in this case. Okay, I think that's all. So any questions? Great, thank you for your listening. So yeah, I'll get back. Yeah, my presentation is that's all.
Okay, thank you, Dennis. Please also, address the comments from the community. So
yeah,
the next
sure.
one, the next one is the system ready. Is Senso in this meeting? Yes. Oh, Senso, okay, I see. Okay, Senso, you can present your screen. Yeah, yeah. Okay. But your voice is a little bit low. So.
How about now?
Yeah, your voice is very low.
Is it fine now?
Can you try that?
No. Okay. Just a second. How about now?
Oh, now it's better. Thank you.
Okay. Okay. Hi, this is Senthil from Broadcom. This discussion is about the system-ready feature implementation in SONiC. At present, there is no mechanism to know that the system is up and ready with all the essential SONiC services, and also to know the ports are ready for network traffic. With the asynchronous nature of SONiC, we cannot determine that the config has been applied all the way down to hardware. But however, if we could get the closest up status of each Docker app considering their port ready and their dependencies based on config receive ready, the system readiness could be arrived. With that, A new Python-based system monitor framework is introduced to monitor all the SONiC services, including Docker services running status and also their ready status, which should internally include port ready status on an event-based approach and declare that the system is ready either in or both in syslog and in Redis DB. So this framework gives provision for Docker apps to notify its closest up status. CLIs are provided to fetch the current system status and also the service running status and their app ready status along with the failure reason, if any. So why I have not used Monet here, the existing tool, which is used for service monitoring. Monet takes the polling based approach and it runs in the frequency of every 1 minute. Recently, the critical process monitoring by Monet was deprecated as supervisor does the job. Hence, system health tool, the currently existing tool that depends on Monet for service monitoring does not work. However, there is a container checker in Monet which checks only for the running status of the enabled containers in config DB. So what benefit do we get with this system ready feature? Is that it is the event-based model. So we provide an event-based Python framework which provides flexibility and prompt update on the system readiness and does not hog CPU unlike polling. The focus is on app readiness instead of just relying on app running status. CLIs connect to the daemon running at the backend to fetch the system ready details, so no code redundancy. This feature is also compatible with the application extension framework. Because the application extension framework, what it does is that it allows the signature verified third-party Dockers or features to register in config DB. And once the feature is enabled, it becomes part of either SONiC target or multi-user target. So when it starts, it automatically comes under the system monitor list. However, the app ready status for these Dockers needs to comply with the system ready framework logic to be tracked. So this is about the system ready feature. So what is the requirement with respect to functionality?
I have a question, just a moment, if you can. At the beginning, you mentioned that the system health is not functional anymore. Could you elaborate on that?
Because system health tool is internally invoking Monet summary. So what Monet summary does is that Monet summary focuses on all the platform stuffs like LED status as well as the service status. So here recently the Monet tools feature of critical process monitoring was deprecated because the supervisor D already monitors the critical process of each Dockers. So because of which it was deprecated, and the system health tool will not display the service status. And that too, even if it is enabled, it can only show the running status of it, not the app ready status not the app ready status of the service. So that is the focus here. It is not just the difference is that it is not just we are monitoring the running status of the service. We are monitoring the readiness of the service, as well as the approach is based on event based, which is against the Monet's poll based approach, so that the system ready is up to date whenever a service changes its state.
So Senthil, when you meant by the app ready state, it means that the app has finished the initialization and will start listening for notification, or is it as it consumed the initial configuration and it's done? Can you specify what you mean by app ready state?
Yeah, so it depends. Basically, with as I earlier said, with the asynchronous architecture of SONiC, we'll not be able to verify if all my config has been applied all the way down to Docker. So we are trying to get the closest up status of each Docker app. In that case, if you consider SWSs, let me come down. Okay, so if you consider the SWSS app, So right now in Broadcom, what we consider, how we consider its substatus is that it will be considered up only when its system the service is running state and when its dependencies are met by checking the state DB entries like interface manager, VRF manager, and VXLab manager. So
okay.
the dependencies. Likewise, if you take for a UDLD and STP, it is something that it will wait for the port init done status and the interface DB creation, and then it goes for marking the up status, the closest up status. So that
Okay.
the network can resume, the network traffic can resume.
Shouldn't SWSs to check for port config done something? Why is that only UDLD checking that?
It internally does it.
SWS is it's kind of implicit. Yeah.
Every Docker app does wait for port init done, and then extra. Here I have just mentioned about the extra dependencies it has.
Okay, got you.
Yeah.
So please go ahead.
This is Madhu. I have one question here. So when application readiness, right? So two things, right? One is whether the application fully check all the dependencies and kind of ready to start, right? The second thing is liveness. So let's say now the container or like application started receiving traffic. While serving the traffic, maybe the dependencies got failed because like we have I'm communicating with different applications in different containers, right? Due to network failures. Right? So how do we handle this readiness versus liveness? So do we need to implement any custom health check scripts in the application, and that should be event streamed to this app?
So it is tightly coupled with critical processes, right? Critical process running in the Docker. If any critical process goes down, then the supervisor D, of course, it takes the Docker down, right? So in that case, so we have a common mechanism where when the Docker goes down, we do mark the substatus false, and when it comes up, when it launches also, it is initially marked as the substatus is initially marked as false. And then the application, once it gets initialized, it can actually mark it true again.
So so when I say readiness in the sense like we kind of checking all the dependencies and we mark everything is correct, then we say that application is started, right?
Right.
So then let's say application is started and we are accepting traffic. The application is accepting traffic, and during the time maybe kind of something is maybe hog with the threads or like maybe running out of memory, right? So how do we find it out? So do we have some mechanism to figure it out, like kind of a keep alive kind of stuff, like liveness check?
You see, it is about, see, it's like if you go out of memory, like obviously the Docker goes down, right? So anyway, the service state change, because we as a system monitor framework, maybe like once we come into the topic, right? The system monitor daemon, what it does is like it subscribes to the system dbus. So this system dbus will get the event notification from any task which actually goes down and up, right? So any service which goes down will be notified to this particular subtask in the system monitor, and it takes an appropriate action to update the the system status. So obviously it is linked like supervisor D inside Docker is taking care of all the critical process, and then system D takes care of all the Dockers externally, and sys monitor takes care of all this system D services. So it's like the chain of link.
I think Senthil, one thing is today, right? The app ready status is something like during the startup or when it is shutting down, right? I think question from Madhu is whether that status is getting refreshed periodically, right? To give or to monitor it on a continuous basis. For example, an application updated its up status, and then say for example, for some reason it is stuck. It's maybe it may not have crashed, but say for example it is just stuck on a mutex or something like that, and it's not able to process anything. In that case, it's the app ready status is not really up, right? So we don't have a mechanism to refresh the status continuously, but that's something that can be added as an enhancement.
Sure.
Yeah, Babu, that's where I'm going. Like, do we need So I mean, any custom health checks need to be enforced onto the application. So that's where we go there. But maybe let's have a framework that can be filled in. Yeah.
So one more question.
That's right. So we'll take that.
One more question. When you talk about the app ready, and you said that it's dependent on the app. So who is responsible for publishing the app is ready? Is it within the app's logic that we need to do it, or is it done by some kind of a monitoring?
Right. It's apps. I mean, app should be updating the up status, and then it will be read by our SysMonitor framework logic.
Okay. Because yeah, the reason why I'm asking is we have this app extension, right? So we need to add it to the list of common things that the app need to do. So it would be better to capture that. So that's why I wanted to check. Thanks.
Right. For now, with the application framework, extension framework, it comes under the radar of SysMonitor, the current feature. But the app readiness is I mean, only when the extended application adapts to this framework logic, then the app readiness could be considered.
Yeah, it will be more appropriate rather than relying on the SysMonitor.
Okay. Right.
Okay.
So here, so the functional requirement would be identify the list of SONiC services to be monitored, and then we categorize them into core and all services. So why core? We came up with something. We came up with a logic saying for testing MCLAG functionality, all the SONiC services need not be up, but just ICCPT service along with the core basic services are only required to be up. So hence the functional test can check only for those required services along with core services. So that's the need for this categorization of core and all services. So core is something like we have identified 7 services like BGP, SWSS, management framework, etc. And then all services covers all the Docker services plus SONiC services, SONiC host services. And then a new service is introduced a new service called SysMonitor is introduced to monitor and then declare the system ready. And the provision for Docker apps is given to notify its closest substatus in StateDB, which will be read by the SysMonitor. Then we have the requirement is to launch the syslog, raise a syslog, basically appropriate syslogs, and then appropriate CLIs will be provided to know the current system status of core and overall system status. Then the CLIs can be included in the tech support data collection for debugging. Coming to the warm boot requirement, it is that we make sure that this particular service, warm boot finalizes SONiC service, is monitored as part of all services. So coming to the design perspective, so the main crux is the SysMonitor daemon, which actually tracks the system readiness through monitoring the running status as well as the app ready status. So whenever the system monitor daemon boots up, it polls for the service list status once and then maintains a global dictionary basically. And then it publishes the system readiness. Subsequently, when there is a service state change, SysMonitor gets the event notification for that service and then takes appropriate action and update the dictionary promptly as it is event based. As I said earlier, it is up to date. The system status is always up to date to be notified and could be fetched by the appropriate CLI. Hardly the memory for the dictionary maintained in SysMonitor is just 1 KB. So we don't, I mean, like, there is no disadvantage of memory consumption as well as the CPU hog with respect to this event-based approach. And to be specific with SysMonitor, we have four subtasks. One is for subscription to the system dbus to get the service event notification change, and then we also subscribe to the newly introduced feature table in StateDB, where the Docker apps update their up status. So whenever they update the up status, so this particular subtask gets the notification and take the appropriate action. The main task is something that it actually listens for the events from these two tasks and take appropriate action of checking the unit status and updating the system status in the dictionary. There will be a listener task. Yeah.
One question here, is this somehow correlated to the feature table that exists in the config DB?
No.
Then can we kind of name it differently, because I think that will be kind of confusing, right?
But okay, it is something that I mean, it is almost the same, right? Like it is almost the same.
No, we have Dockers that some Dockers which I'm not sure if everything is associated with the feature, but if it is one-to-one mapping, then it's fine. Otherwise, I think that will be kind of misleading and confusing.
It is almost same. It is almost same. Whatever feature is enabled in config DB, those features will be in state DB as well. Like each Docker is going to update it, and sysmonitor is going to fetch the feature table status from state DB only for those features which are enabled in the config DB. So,
but let's assume there are some tasks that are running in the host, like we have host config D, CICL manager D. These are other important tasks that they don't belong to any feature, correct?
Right. Here feature, I'm talking only about the Dockers. Feature is going to, I mean, it's going to point only to the Dockers as equivalent to the config DB, because a host config DB does not come under features of config DB.
Yeah, I agree with that. My question is, how do such tasks which run on the host update their status?
No, that's what, like here the crux is that it is not about, I mean, the only we are talking about the Dockers updating the status, not the host services.
Okay.
Host services, yeah. Host services does not. We are just going to check the running status of the host services. Only for the Dockers, we do check for the up status.
Okay, so for them, it's just the sysmonitor checking whether it's up or not. They don't update the state DB, correct?
That's right, yeah.
I feel maybe we should check with the host config D, because host config D at least take 10 to 15 seconds of initialization and goes feature by feature, and it is not ready until it does that. So I believe we cannot just say host config D is ready once the service is up. So we need to consider that.
Okay. Okay, I'll make a note and then get back. Yeah, sure. Thanks. And going forward, we have a listener task as well, where it listens to this particular send socket for the show command to communicate with the sysmonitor to get the current system status. Because as part of this main task, we do maintain a dictionary of service status. So this dictionary will be passed to the show command through this socket to be shown to the user. And as I said, so the categorization of service will be like this. Core services are identified to be these 7 services, and these will be a predefined one. And all services, it covers the enabled services from the feature table of config DB. And also, since the idea is to cover all the SONiC services, we do not cover the general system services. So sysmonitor tracks services under multi-user target and SONiC target. So this basically covers the SONiC Docker services, and kind of all services will be covering all the SONiC Docker services and host services. So the main framework business logic will be this. See, it is we intend to align the services within the framework to flag the status as not up or failed if the service is not running when it was intended to be running. So basically, it is not just merely displaying the current status of the service. For example, if BGP is down, a user has stopped the BGP. When you issue, as per the system framework logic, we flag it as failed, because even though the user has disabled it or stopped it, but as per the core logic, core service logic, okay, all these services are to be up and running. But it is not running. So if the service is not running when it was intended to be running, then we flag it as failed. So that is the business logic here. So core service must be active and running, and then the Docker's up status.
So Sendil, can we mark it as like right? It's not actually failed. It's a user interrupted, or user stopped the service, right?
Right.
Can we put it appropriately, because it will be confusing whether it's actually failed or like it's a user intended operation.
Okay. Okay, I mean, the intention was this. Okay, in that case, we can flag as not okay, something like that.
Yeah.
Or not up, not okay.
Sure.
Fine, I'll take a note. So any core service must be active and running, and the Docker substatus should be true to consider it to be up. Otherwise, it is not okay. For all services, we follow this order. It should be loaded either of these enable runtime static, and then it should be active and running, or active exited state services are considered okay. And then these are the protocols basically. Like if a particular service is fail, it's in fail state, then we flag it as fail. Activating state, it is like starting, and deactivating is stopping. Then we also have an inactive category. So basically, one-shot services tend to go to inactive state. So one-shot services are considered as okay if they are inactive exited. And then other services in inactive state are considered to be failed. So one more point to note is that any service type other than one-shot, if by default goes to inactive state, we mark we actually request that particular unit, service unit, to add remain after exit equal to yes to be added to the service unit file to be in line with the framework, or that particular unit service needs to be one shot. If it is behaving as a one shot service, then it has to be its type has to be changed to one shot. Otherwise, comply with remain after exit, because we have to make the services to be in line with this framework. So this is the topic about Docker apps to mark losses of status. So for this, what SysMonitor does is like we have a config DB change and the state DB change. So for config DB change, what a Docker if decides to mark their up status in state DB, it has to input this feature table from config DB with this flag, check up status flag set to true. So basically, we already have a particular feature like BGP state enabled. Then we need to add an entry. That particular Docker needs to add an entry like check up status equal to true. So only then SysMonitor goes and checks the app ready status from state DB. If this particular entry is not there, then the SysMonitor does not care for the app readiness. So state DB changes, it looks like this. So this is how it looks. So any Docker which updates its up status, so it will be like in the state DB, it will be like BGP. Then if there is any failed reason, and then the time up status equal to true. If the up status is equal to false, then there will be a custom string written here like transceiver daemon is not up. So this value will be fetched by the SysMonitor to know this particular Docker app ready status. And also we have we also post the core system status to state DB, not the all system status, like in this format, because right now a few Dockers like this SNMP and TAM just rely on if the core services are already up or not. So we came up with this particular posting of system readiness, core system readiness to state DB, which will be read by the other non-core services. So coming to the syslogs, it is syslog to be generated for any SONiC, service state change, either to active or active to inactive or inactive to active. And the overall system readiness will be shown like this. System is not ready, core services are not up. System is not ready, one or more services are not up. So this is for core service and this is for all service, like this. And also any service state change will be flagged like this. So it is the active state and this is the substate of any service. Coming to the CLI part,
question.
Yeah.
Yeah. So during boot up, things are like hectic, right? So during that time, is this service kicked in already? How do you prevent things like, just not,
Monitor boots up after the database comes up. After the database Docker comes up. So it is designed in such a way that this particular service starts after database service. So it is in the boot up.
Yeah, some servers actually will come up like a couple minutes after the core or other services come up.
Right.
So in those cases, how do you flag those?
Yeah, it flags.
It doesn't not ready yet.
Right. It actually flags that system is ready, a system is not ready, and it shows that, okay, as I said, there are states like activating. So it will be like this, starting. So it will be like this. So BGP, if you take, okay, this is starting. So the running BGP's running status is okay, but the app ready status is still it is initializing. So it will be like this. Even if even this can be starting like this. NTP config is starting. So from this, we'll know that the system is initializing and it is coming up.
Yeah, so you will update this in the state DB as well, right? Is this what you update, or the service that is, let's say
Not the
BGP?
state, not the state DB. We actually maintain a dictionary in the sysmonitor, and this particular show command will fetch from the sysmonitor and show this status.
Okay.
Okay, not everything, only the overall system status will be posted to the state DB. Like system is ready with all the services or system is not ready. It's like that.
Okay, so this one just helping the user to know what's going on in the overall system. There's no how do I say, repair actions or anything attempted by this, right?
That's right, yeah. To know the current system status, yeah.
Okay, thank you.
And so these are the syslogs. Coming to the CLI part, it is we only support the click commands because as we need to monitor the management framework Docker service itself, we'll not be able to support Clish, because if management framework service is down, Clish will not work. So that's the reason, like we are sticking only with the click command. So we have two flavors: show system status core and show system status all. This all will have two options: brief and detail, which we'll see below. So the format will be like, the display format will be like this. Show system status core will display the overall system status, and then it lists the service name, service status. This is the service running status, app ready status, and then the failed reason if there is any. So these are the core services. And if the system is not ready with the core services, then it shows like this: BGP has failed, and the failed reason is inactive. If the user has made it inactive, maybe like once as the other contributor suggested, we can make this change to not okay.
Senthil, one question here. Some of the core services like management framework do start late, like 3.5 minutes late. So when we kind of run this command after boot up, when some services are started and some didn't, what will be the status? Will it show failed, or will it show like ready or something?
Starting like this.
Starting, okay.
Yeah.
Okay, thanks.
Yeah. And for all, it is that, okay, it covers all the Docker services as well as the SONiC services. So this will be like, the message will be system is ready with all the services, and then there will be a list of services and its status. So if, for example, for the failed reason, this guy, AAA stats T is in failed state for the start limit hit failed reason, and PMON, platform monitor, the running status is okay, but the app ready status is failed. For this reason, the transceiver daemon is not up. This is a custom string. While marking the up status, so this particular custom string has been appended by the PMO Docker.
So another question, here you have mentioned the feature status for all the host services like AAA and CACL manager. But I believe we do not have a feature table entry. So if we at all, we need to change the configuration of those features, like check status, how do we do that?
In that case, yeah, we need to come up with a new table or so.
So can you please make note of it? I think this HLD is missing the part of the host services, both at the state as well as at the config.
Okay, sure. Yeah. Initially, like we thought only to go with the Docker services. Okay, if the host services are also to be considered, we can do that.
Yeah,
but that will conflict with feature tables, right? So the sense feature table
we can
today accepts Docker.
Yes, Venkat. Yeah, we can come up with a new table.
Yeah, new table. That's what Senthil is mentioning.
Okay. So then the feature table won't be used. Is that what it is, or like I'm missing something?
It will be used for the Docker services. We can use feature table. For the host services.
Host services, yeah, we kind of need to use a different table.
Okay. So Senthil, when I restart the Docker, right? How soon the status of the service status and application ready status will be reflected in the command, in the click command?
So it's like once as we have subscribed to the dbus system dbus,
Right.
it just
Right.
gets in seconds, right? Like,
Okay.
so with
you
that,
okay. Go ahead, sir.
yeah.
So it
And
will be
then
reflected immediately.
Right.
Okay.
That's right. Yeah, it will be immediately reflected as it is event based and that particular service based. So if PMON goes down, then immediately this dictionary will be updated with this monitor, and then it can be fetched by this system status.
Dictionary will be updated based on the number of messages in the queue. Am I right? Because you
Yes,
said
that's right. But
yeah.
yes, as we are there are like consider okay 5 units have gone down, 5 services have gone down at the same time. So of course it will be put into the queue, but the processing time is very quick, below a second time, because we are going to check only for that particular first. If PMON is received, then that PMON's service status and the app ready status will be checked quickly and then updated. So the service time, the processing time is very quick. So it will not delay. There will not be any delay in updating the status of every service and the overall system status.
Okay, so with respect to application ready states, right? So I think you mentioned, if I'm not wrong, the application has to update the state DB, correct?
That's right. Yep.
So when the Docker itself going down, the state DB will still say that it's up, correct? Application ready status is up.
There's a generic code where whenever the Docker starts and Docker stops.
I think there is a Docker exit listener. Yeah.
Okay.
That can update it.
We handle that, or?
Yes, it is handled. Yeah, we handled it as to be false. Yeah, the app status is false, and even then, even if the app ready status will be read only when the service status is running.
Okay.
There's no use of going and reading the app ready status when the service itself is not running. So that check is there.
Okay.
And in addition, we also mark app status as false during Docker start and Docker stop.
So Senthil, one more question, right? When we take a feature, it's mapping to a Docker, and the Docker has multiple processes. Let's assume if one of the process goes down, the logic is completely internal, right? Whether to make the Docker as running up or down based on what service has failed.
It is so these Dockers consider the critical processes. In fact, they consider the critical process. So if any one of the critical process goes down, then the supervisor proc listener takes care of taking this Docker down, and then the system.
Okay. So let's assume I have a app-based feature extension where I have a Docker and then I have a list of process. Some of them are not critical. So in that case, by default, it will not consider it as down. Only for the critical process, it will consider, right? Unless I update the state DB. Okay.
That's right. Yeah.
Okay. Thank you.
So it is up to the Docker's nature. Like if the Docker has the independent features, and so these independent features has to update an intermediate table. They can maintain an intermediate table in Redis, and then once after all these intermediate tables are up, and then they can flag the overall up status for that particular Docker.
Okay. Thanks.
It's all up to the Docker owners to mark the status. So basically, like we can consider like whenever like as I said in UTLD, like only when the config receive during the config receive ready state, then they can mark the up status. So it depends. Coming back to the CLI part, so we have an option for all brief. So this just displays whether the system is ready or not ready. That's it. So this actually helps the functional testing. Hence we brought up with this brief option, and then there will be a detailed option which can be included in the tech support, where it will list down all the services and its states with the failed reason along with the system control status of it, so that we know instead of logging into the system and then knowing what has happened for this failed state, we'll know this has gone down with the start limited, and some extra information will be there in the status. So this particular show system status, all detail is embedded to the tech support data collection. And regarding the serviceability and debug, so as I said, syslogs are helpful to know in knowing the any particular individual service has gone down or up, and as well as the overall system status for core and all services. And we also have a ready-made show command which actually communicates through socket to the sysmonitor and gets the updated result quickly. And then, as I said, in tech support, we included this CLI to be saved to the dump in the name of this particular file. Warm reboot support. Sysmonitor monitors the running status of this warm boot finalizers. As of now, this particular service running status is monitored, but this should be enhanced to hook the actual completion of the warm boot. So that we are working on, which will be added later. So these are the unit cases.
I think you missed the part to update the Yang model. Since you are adding a new field to the feature table, can you also please capture that?
Yang, it's just a click CLI, right? Like,
no, we are changing the feature table, like check up status or something. We are introducing a new field, right? So that requires a change in the Yang model. There is a feature table based Yang model. So if you don't modify, I think that will be a little problematic.
Okay, I'll make a note. I was not aware of it.
Yeah, if you don't add, then Yang validation will fail, and when we do breakout, that might not work at all. So there is an inherent dependency there. So please make a note.
Sure. Yeah. Noted it. Sure. Thank you. And that's it. Okay, these are all the test cases went through. And thanks. And this is about the system ready. Thank you.
Cool. Yeah, I think this feature is very helpful for the SONiC community, especially when we use this product. So thanks for the proposal.
Yeah, thank you.
Thank you.
Thank you. See you.
Yeah, thanks everyone.
Thanks everybody.